Hello to everyone. This is Shantan Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Subject is matrices and calculus. Today we are going to discuss about that solving the system of non-homogeneous equation whenever the variables are involving in unknown values. Before going to discuss here, first we need to discuss that what is the meaning of the system of linear equations, and again what is under the system of linear equation, what are the topics which is covered. Here, the system of linear equation. First of all, we need to discuss, for example, consider the three equation. One is the a11x plus a12y plus a13z is equal to b1. Second equation, a21x plus a22y, a23z is equal to b2. Third equation, a31x plus a32y plus a33z is equal to b3. These are the considered system of three linear equations. And based upon these are the three system of linear equation, here how to consider in terms of ax is equal to b. That means with the help of the three equations, here while we are consider a, the matrix of a is nothing but the coefficients of x one by one, a11, a12, a13 in the first row, and second row a21, a22, a23. The third row a31, a32, a33. And here it is called as a coefficient matrix. Next, x. The x is nothing but in the three equations, the totally the number of variables are 3. One is x comma y comma z. With the help of these are the three variables, we need to consider that x is a matrix. And this is called as variable matrix. And based upon the constant values, one is a b1, b2, b3. Here it is treated as b is a matrix, the constant terms which is 1 by 1 b1, b2, b3, and it is called as a constant matrix. And with the help of this a, x and also b, next we need to discuss what is the meaning of the augmented matrix. The augmented matrix is nothing but the collection of a comma b written side by side is called as a augmented matrix. As we know that the system of matrix, the equations already we consider a x is equal to b, and again it is considered within the box that is a matrix a comma b side by side is called as a augmented. It is denoted a b or in other terminology a b also. That is nothing but where the matrix A is nothing but already we in the previous slide we discussed a11, a12, a13, a21, a22, a23, a31, a32, a33. And again with the help of this matrix, and again B is a matrix also, that B is nothing but column matrix, that is a b1, b2, b3. And with the help of that A and B, if it is considered within a single matrix, that is a comma b written side by side is called as a augmented matrix. And here the augmented matrix order is always that is depend upon the A and also B is a matrix. Here the A order of the matrix is a 3 by 3 and B order is a 3 by 1, and together it is a augmented matrix is always that is a 3 by 4 is a matrix based upon the given three equations. Next we will go to discuss what is under the system of linear equation, what is the meaning of non-homogeneous linear equation. Here the non-homogeneous linear equation is nothing but whatever we assume the previous equation, these are the three equations, and again with the help of these three equations where here provided b1, b2, b3 which is not equal to 0. That means whenever the equations are, it is a constant values are occur, that is the meaning of non-homogeneous equation. That means b is always which is not equal to 0. And the system of homogeneous linear equations. The system of homogeneous linear equation is nothing but when we are observing the non-homogeneous and homogeneous. In the non-homogeneous, if it is b is not equal to 0. And whereas the homogeneous equation, like the examples are the three equations a11x plus a12y plus a13z is equal to 0, a21x, a22y, a23z is equal to 0, a31x, a32y, a33z is equal to 0. While we are observing in these three equations, b is equal to 0. That means in the three equation which is not involving any single constants. That means here b is always the values are 0. The difference between the non-homogeneous and homogeneous, the non-homogeneous equation is always b is not equal to 0, and homogeneous linear equation is called, that is whenever the b is equal to 0. That means ax is equal to 0 is the equations. And with the help of this one, the consistent system. The consistent system is nothing but a system of equations have at least one solution. That means under the one solution is nothing but here either it may be one solution or like number of infinite solution. Together at least having any one solution is a mandatory. And it is an inconsistent system. The inconsistent is nothing but whenever the equations are having the no solutions. Here, these are the two things you need to remember under the system of homogeneous or as well as the non-homogeneous linear equation. That means the consistent is nothing but it has at least one solution. The inconsistent is nothing but it has no solution. Now, we will go to discuss under the non-homogeneous linear equation. Today we are going to discuss the topic. Here, that is Ax is equal to b. Under the Ax is equal to b, here the two conditions, one is a consistent and again second one is a inconsistent conditions. And here the consistent is nothing but based upon the rank k and rank kb, because of here b is not equal to 0. And here if it is rank k is equal to rank kb is the condition, that is the meaning of consistent, and inconsistent is nothing but it is rank k is not equal to rank kb. That means here row, it is meaning of the rank. It is rank is always denoted with the symbol is, that is a row. It is called as a row. Here under the consistency, once again as we discussed in the previous slide, the consistent is nothing but it is having the solution. The solutions are nothing but based upon the two conditions. The one is a unique solution, that is also, and the other one that is infinite many solutions. Here the unique solution. The unique solution is nothing but based upon the category of rank A is equal to rank AB. Whenever the condition the rank A is equal to rank AB is equal to n, the condition is known as a unique solution. That means rank A is nothing but the given matrix rank. Rank AB is nothing but including the augmented matrix. Based upon the rank A and rank AB is equal to both are the same, and including that n is also is equal to, the condition is a unique solution, and infinite number of solutions. The infinite number of solutions is nothing but it is rank A is equal to rank AB is less than n. Here this is the two difference one by one, that is unique solution is always is equal to n, and infinite solution is nothing but it is less than n is a condition. Here n, that n is nothing but it is number of variables. The number of variables is nothing but, for example, in the equations like having three variables like x comma y comma, that is z, this is nothing but it is called as n is equal to 3. For example, whenever the equations are involving like based upon x1 comma x2 comma x3 comma and x4, and it is nothing but here n is equal to 4 is the number of variables. That means here based upon the given equations, and again we need to assume in the matrix and again including the augmented matrix, we need to find out what is the rank A, that is by using the echelon form and including the rank AB also. Based upon the conditions, here rank A is equal to rank AB is equal to n is called the unique solution, and moreover rank A is equal to rank AB is less than n, the condition is known as a infinite number of solution, where provided here n is equal to the number of variables. And here other side, that is inconsistent. The inconsistent is nothing but rank A is not equal to, that is rank AB. These are the under category of, that is a non-homogeneous system of linear equations. Next we'll go to discuss if the equations are like homogeneous linear equations. Here the homogeneous equations is nothing but always here b is equal to 0. That means it is in presence of b is the value is 0. That means again there is no constant values. Here for example ax is equal to c, and here also under the category of ax is equal to 0, here the two conditions we are going to divide. Here one is a consistent, under the consistent like the two conditions, one is a like rank A is equal to rank AB is always the consistent under the homogeneous equation. Here these are the two conditions, one is a unique solution, and unique solution is also known as that is a trivial solution. And other side, it is infinite number of solutions. The infinite number of solution is nothing but it is also called as a non-trivial. Whereas unique solution is a trivial, the infinite solution is that is a non-trivial, that is a solution. And based upon this trivial and again that non-trivial solution, the condition with the help of the echelon form like rank, it is a whenever rank A is equal to that is rank AB, and we need to remember that B is equal to that is a 0, and again is equal to n is a condition is known as a trivial under the consistent that is unique solution. And here the infinite many solutions. Under the infinite many solutions, the condition is rank A is equal to rank AB is less than n. And here also that B is less than n is a condition. B is equal to that is 0. And here also that n is nothing but the number of unknowns, that is number of variables. Based upon this, under the homogeneous equations, that means here always the homogeneous equations are always it is a consistent. Under the consistent, it is having the solutions that is nothing but either unique or infinite. The unique it is called as a trivial. The infinite solution is called as that is a non-trivial solution. Now clearly the flowchart that is a linear system of homogeneous equations. That is together here it is showing that non-homogeneous and also the homogeneous system. Here what we discussed just now, that clearly we are going to observe here that is a one by one, that is a non-homogeneous and also homogeneous. Here one side the non-homogeneous equation we clearly understood it is one is a consistent and again the other one is a inconsistent condition. Under the consistent here already we, and again other side that is a homogeneous. Under the homogeneous it is a trivial and again non-trivial solutions. And one other side, the left side it is under the consistent. Again we already discussed about the unique solution and infinite solutions. And here unique is nothing but that is a like rank A is equal to rank AB is equal to n. And here the infinite solution is a rank A is equal to rank AB is less than n. And provided that is n is equal to that is a number of variables that depend upon the given equations. Sometimes it is xy 2 variable, sometimes xy comma z, and sometimes x1, x2, and again in terms of that is a variables. And whereas it is xy is a 2 and xyz is a 3 and again x1 it is also 3. That depend upon the equations we need to observe in the given equations. Here what is the n term that depend that n is called as a number of unknowns, that is a number of variables. Here that is a let's say it is a condition is unique and again right side is a infinite solution, that is a rank A is equal to rank AB is less than n is the conditions. Here now based upon the non-homogeneous equations, here what is the working rule, that means method to solve the system of linear equations. Here if the equations are like that, according to consider the three equations. Here our goal is to find the value of x comma y comma z, and these three equations are considered the system of linear equations. And based upon that, according to first we need to consider in terms of Ax is equal to b, and here that A is the coefficient matrix, that is 1 by 1 that x y z, and again second equation x y z coefficient, and third equation is also x y z coefficient, and again here it is called as a coefficient matrix. And x, that x is nothing but in the given equations the different variables are x y z, and again b, it is the variable matrix, and here b, that b is nothing but it is a constant matrix, that is 1 by 1 b1 b2 b3. And according to here method to solve the system of equations, here after that consider that Ax is equal to b, we need to write what is the augmented matrix. Here that collection of A comma B written side by side is called as a augmented matrix. Here already here A and B, that is a coefficient matrix, and B is a column matrix, together written side by side is called as a augmented matrix. And after that consider augmented matrix which is reduced to echelon form, that is also known as a row echelon form, by applying the back substitution method. And again to solve the equation to find the variable, that is required our concept of the x comma y comma z. Now, what is the working rule? Under the working rule for to solve the system of linear equations, here the same three equations, we need to assume in the augmented matrix, that is augmented matrix from the Ax is equal to b, and reduce it to echelon form by using the back substitution method to find the rank A and rank AB and depend upon the given variables. And again, we need to find the solutions. Here, our today topic is the solving the system of non-homogeneous equation whenever the equations are involving unknown values. Like unknown values are nothing but it is including like lambda, mu or any other terminology, and again the unknown values are a comma b. That sometimes that depend upon the equations are involving lambda, mu, a, b. Like these are the unknown values we need to consider. Here, according to one, we need to discuss one problem. For which value of lambda and k, the following system has no solutions, unique solutions, and infinite number of solutions. Here, the equations are like one by one, x plus y plus z is equal to 6, see x plus 2y plus 3z is equal to 10, and x plus 2y plus lambda z is equal to mu. While we are going to observing here, the equations are involving like unknown values. In previous lectures, we discussed whenever the equations are involving only the variables under the homogeneous equation and non-homogeneous equation. But in this case, here the equations are involving like unknown values. That means lambda comma u. If the equations are involving, then how to find out? That is with the help of the given equations are like no solutions and again the infinite solution like under the unique solutions. Here, if you want to discuss this one, first of all, we need to remember the case under the non-homogeneous linear equation. What is the meaning of the unique? What is the meaning of infinite? What is the meaning of the no solution? When it is satisfied the condition. Here, again you need to recall the no solution is nothing but it is rank A is equal to not equal to rank AB. And here, the unique solution. The unique solution is nothing but rank A is equal to rank of AB is equal to n. And here, the infinite number of solution, the rank A is equal to rank of AB is less than n. And based upon these three conditions, if you remember, then only it is surviving. When the equations are like unique and no solution and infinite, then only it is possible to find the values are lambda and also mu is a value. Now, we'll go to discuss according to the working rule. Here, according to the working rule, first, any given equations we need to consider in the form of Ax is equal to b. Here, A is nothing but the equations are, while we are going to observing here, first equation coefficient is 1, y coefficient 1, z coefficient 1, that we need to replace here the first row, and second row here the second equation x coefficient 1, y coefficient 2 and z coefficient 3, and the third equation x coefficient 1, y coefficient 2 and z coefficient that is lambda. That these three values we need to replace according to the formation of 3 by 3 matrix. And here x, in that x is nothing but the equations are involving only the three variables, that is x comma y comma z only. Therefore, here that x is written in the form of like column matrix, that is x by z, and here b is equal to, in the given equation the constant values are 6, 10 lambda, 10 and also mu. Here the three values we need to replace in branch of b, that is a constant matrix, it is a 6, 10, that is a mu is a value. And after that, consider like Ax is going to be, we need to write in the form of, that is a augmented matrix. As we know that already we studied, we understood the augmented matrix is nothing but the collection of A and also B written side by side within the single matrix. Therefore, here AB is nothing but it is a matrix and B matrix together. The matrix is reduced to like according to this is the augmented matrix. And here, after consider the augmented matrix, now our concept is reduced to echelon form of a matrix. Here, while we are going to observing the echelon form, that based upon the echelon form conditions, here in this particular matrix, we need to apply here that one value is reduced to 0 and one value is also reduced to 0, and here also the 2 is reduced to 0, then the matrix is reduced to echelon form, that indirectly. Therefore, here that 1 is reduced to like that 1, 0, that means R2 minus, that is R1. And again, that second, the third row, one's value is also with the help of R3 minus R1. Then the matrix is reduced to automatically in presence of 0 and in presence of 0. And here also 0. But in presence of the lambda is equal to lambda minus 3. Like according to these are the matrix. And here also the other values we need to change the values. Here, by using the like according to reduced to echelon form, finally the matrix is reduced to like this the matrix. Here, while we are going to observing in this echelon form, here we need to find out when it is a condition, like for first condition it is a no solution, and second condition it is a unique solution, the third condition is a infinite number of solutions. Here, while we are going to observing the unique solution, here again our condition is required rank A is equal to rank AB is equal to N. And finally, in the given matrix, we know that N is equal to 3 because of here N is the variables are x comma y comma z is a different 3 variables. And if it is rank A is equal to rank A is equal to N, and in this here particularly, we know that here this value is a 3, that N is a 3, and automatically which is required that rank of AB is also 3 and rank A is also 3 is the conditions. Because of we know that N is equal to 3 already existed. And automatically we require to satisfy rank A is equal to rank AB is also compulsory 3. And here, while we are going to observing here for unique solution, here the meaning of here in presence of it is a first is 0 and second one is 0, it is existed. And in presence of lambda minus 3, that is nothing but it is a lambda is equal to 3. And again here mu minus 10 is equal, that is a mu is equal like the 10. But here our required condition is if it is lambda minus 3 is equal to 0, the rank will be 2. But according to here, our concept is rank K is equal to, that is a 3 is satisfied. The rank K is equal to 3 is compulsory, it is required to satisfied whenever lambda is equal to not equal to 3. That means it is rank A is not equal to 3, then only the rank A should be the 3. And if it is rank A is equal to 3 and based upon that mu minus 10, either it may be 0 or it may be not equal to 0. Because of if it is rank A is equal to 3, the depend upon for any values of mu, the rank AB is also compulsory, it is a 3. Here based upon the condition, if it is a required that unique solution, here it is compulsory satisfied, it is lambda is not equal to 3 and moreover mu is equal to for any real value. Then only it is a condition is satisfied the unique solution conditions. That is the meaning of here based upon this echelon form, the matrix is lambda is not equal to 3 and mu belongs to R, then only the rank of A it is equal to the rank of A is equal to rank of AB is equal to N is a satisfied. And next one, that is a unique solution, for example. And in this unique solution, if we remember the condition, the no solution, then only it is existed. And no solution is nothing but rank of A is not equal to rank of AB. But here with the help of this echelon form, here in presence of rank A is not equal to rank AB. That means compulsory in presence of lambda minus 3, the first term it should be, it is a 0 and second term it should be not equal to 0. Then only rank A is not equal to rank AB is a condition. And if it is required to satisfy this condition, compulsory it is lambda minus 3 is equal to 0, that is lambda is equal to 3, then only the rank A should be, it is a 2 and rank AB is not equal to, that is a condition. Based upon such type of this is the knowledge, then only it is able to get that rank A is not equal to rank AB. That is the meaning of lambda is equal to 3 and mu is not equal to 10. And further, we need to find out the condition is like infinite number of solutions. The infinite number of solution is nothing but, again, here we need to remember the infinite solution is nothing but rank of A is equal to rank of AB is less than N is the conditions. And in this also, as we know that already N is equal to, that is a 3. that is a different variable conditions. And here, if it is required n is equal to 3 means it is compulsory satisfied less than 3 is the rank. That means it is rank A is equal to rank AB is satisfied, and moreover it is less than 3 is also satisfied. If and only if it is a lambda minus 3 is equal to 0, as well as here, that is the meaning of here, is equal to both sides are 0. Then only it is a rank A is equal to rank AB is less than 3 is a condition. And if and only if lambda minus 3 is equal to 0, that means lambda is equal to 3 and mu is equal to 10, then only the rank of a matrix is a constant and having the number of infinite solutions. And this is a simple example for the system of non-homogeneous equations under the unknown values. The condition is unique solution, infinite solution, and also no solutions. Again, we'll go to discuss one other problem with the help of the non-homogeneous equations. Investigate for what values of lambda and mu the equations like x plus y plus z is equal to 6, x plus 2y plus 3z is equal to 10, x plus 2y plus 3z lambda is equal to mu have no solutions, unique solutions, and infinite number of solution. Here also, if you remember the condition like no solution, it is rank of A is not equal to rank of AB, and here unique solution rank of A is equal to rank of AB is less than n, and infinite solution like is equal to n, and infinite solution is rank of A is equal to rank of AB is less than n is the conditions. If and only if these are the conditions are satisfied, then only we can say the given equations with the help of the no solutions, unique solution, and infinite solution. And anyhow, first the given equation written in the form of Ax is equal to B, that where A is the matrix is a coefficient matrix and X is the matrix is a variable and B is a constant matrix, and with the help of that Ax is equal to B, if it is written in the side by side is the augmented matrix, therefore the collection of augmented matrix is nothing but collection of A comma B written side by side. Here already we consider that is A and also B. Together AB is a 1 1 1 6, 1 2 3 10, 1 2 lambda mu. This matrix here that n is nothing but the number of different variables are 3, since one is x, y, and z is a variable. And with the help of this n, first of all, augmented matrix is reduced to echelon form by applying the here R2 minus R1 and R3 minus R1. It is clearly with the help of that R2 minus R1, and again the first row it will be that is a 1 1 1 1 6, and second row 0 1 2 4, and the third row 0 1 lambda minus 1 and mu minus 6, and it is also not in the echelon form. And further we need to apply one more row operations, that is together with the help of R2 and R3, it is R3 minus R2. The matrix is reduced to clearly that is echelon form of a matrix. Here it is clearly in the form of the echelon form. And with the help of this echelon form, we need to find out the lambda value and k value, like lambda value and also mu unknown values, by using the condition of no solution, unique solution, and infinite many solutions. Here, for example, the first case, with the help of the augmented matrix, the first case, it is for no solutions. For no solutions, as we know that according to rank A is not equal to rank AB. That means no solutions. And if and only if the rank A is not equal to rank AB, if it is required to satisfied, if and only if it is a lambda minus 3 is equal to 0 and mu minus 10 is not equal to 0. Then only if it is lambda is equal to 3, the rank A is equal to 2, and mu minus 10 is not equal to 0, the rank AB is also that is a 3. Therefore, based upon these two conditions, it is rank A is not equal to rank AB. Therefore, the system will have no solutions. And here, similarly, if it is required to find out the unique solution, the unique solution is nothing but based upon the rank A is equal to rank AB is less than n. That means here in this condition, as we know that n is equal to already we know that is a 3. If it is a n is equal to 3 and automatically rank A is also 3 satisfied, rank AB is also we need to require the 3 conditions. If and only if it is also lambda minus 3 is not equal to 0 and depend upon the mu value, it is rank AB is also, that is a 3 conditions. Here, that is the meaning of lambda minus 3 is not equal to 0, that means lambda is not equal to 3 and mu have any value. And based upon this one, it is rank A is equal to rank AB is less than n is equal to n is the conditions. That is the meaning of for unique solutions. And similarly, it is an infinite many solutions. For example, if it is required to satisfy infinite many solutions, that means the condition rank A is equal to rank AB is less than n. Rank A is less than is equal to rank AB is less than n. And here also, as we know that n is equal to 3 and it is required to satisfy less than 3 and moreover, and rank AB is also satisfied rank AB. That means, for example, it is rank A is equal to rank A2, then only the condition is less than 3. If and only if lambda minus 3 is equal to 0, that means lambda is equal to 3 and mu minus 10 is equal to 0, that is mu is equal to 10. Based upon these two values by equating, then only rank A is equal to, that is rank AB, it is a less than n is the conditions. That is the meaning of here. It is showing clearly the given equations are no solutions and again the infinite unique solutions and also the infinite many solutions. Similarly, we need to take one other example, like investigate for what values of A and B the equations are the no solutions and unique solutions and infinite number of solutions. And here also, first we need to assume the equations in the form of X is equal to B, where A is equal to 1, 1, 1, 1, 2, 2, the third row 1, 9, that is A. And similarly X, X, Y, Z, and B, 3, 6, that is a base condition. And here, if it is considered in the like augmented matrix, that is a collection of AB written side by side, that is nothing but together it is a 3 by 4. It is augmented matrix, that is order. And again, here also we need to reduce it to echelon form by using the elementary row operations. Here also, we apply R2 minus R1, R3 minus R1. The matrix is reduced to, like according to, this is the following matrix. And here, it is also not in the echelon form. While we are going to apply, that is, we need to reduce it to Z8 with the help of that R3 minus 8 R2. The matrix is reduced to like 1, 1, 1, 3, 0, 1, 1, 3, and again 0, 0, A minus 9, B minus 27. And here it is clearly showing the echelon form of a matrix. And with the help of this echelon form, we need to find out A, B, for what values of A, B, the equations are no solutions and unique solutions and infinite number of solutions. Now, we'll go to discuss. For example, whatever you obtained in the previous slide, it is echelon form. For first one, if it is required to find out no solutions. Again, here also, rank A is not equal to rank AB. If and only if it is rank A is not equal to rank AB is nothing but that A minus 9 should be 0. Then only the rank is 2. And again, B minus 27 is equal to not equal to 0. Then rank AB is equal to 3. Then only it is satisfied rank A is not equal to rank AB. That means if and only if A minus 9 is equal to 0, that means A is equal to 9 and B minus 27 is equal to 0 and B is not equal to 27. Then only the system of equations are like no solutions. And similarly for unique solutions. The unique solution is nothing but the condition we need to remember. The rank A is equal to rank AB is equal to n. In these three parts, we know that n. That n is nothing but that is a 3. That is the meaning of here x, y, z value. As if you know that rank A, n is equal to 3, it should be compulsory rank A is equal to rank AB means rank A is also 3, rank AB is also 3. If and only if that A minus 9 is not equal to 0, then rank A is equal to 3 and B minus 27 either it may be is equal to 0 also or not equal to 0 also, the rank AB should be, that is 3 conditions. Therefore, by this case only, that system of will have the unique solutions. And similarly, infinite number of solutions. And infinite number of solutions are also same. The condition rank A is equal to rank AB is less than n. As we know that here also that n is a 3, that is 3 is equal to x comma y comma z. And here it is satisfied the less than 3 means, and moreover these both are the same, that indirectly it is a rank A is equal to rank AB must and should it is a 2. If and only if A minus 9 is equal to 0 is the rank is 2 and B minus 27 is equal to 0, then only the rank AB is equal to 2. Then based upon these two conditions, it is a system of linear equations are like infinite solutions. The conclusion here, it is for first one is no solutions, A is equal to 9 and B is not equal to 27. And second one, A minus 9 is A is not equal to 9 and for any values of B value. And moreover, the third one, it is A is equal to 9 and B is equal to 27. Then only these are the three cases are satisfied according to one by one. One is no solutions and in unique solutions and infinite solutions. And similarly, these are the like other examples one by one. These are also the no solutions, unknown solutions, and again here also infinite number of solutions. By according to the equations we should consider in the augmented matrix and reduced echelon form, and here also the matrix is in the clearly satisfied the echelon form. For no solutions, here also rank A is not equal to rank AB. That means lambda minus 1 is equal to 0, and again moreover that mu minus 6 is not equal to 0. And again the for unique solutions, and here also lambda is equal to not equal to 1 for any values of mu solutions. And again similarly infinite also lambda is equal to 1 and mu is equal to that is a 6 also. Based upon the three conditions, here also clearly we understood the equations are the no solutions and unique solutions and also infinite number of solutions. And similarly the other examples like same the pattern, the equations are like no solutions, unique solutions and infinite number of solutions that depend upon the like echelon form, depend upon the conditions of and depend upon the number of variables. We clearly understood the meaning of the equations are the unique and infinite and also the number of infinite solutions. Like already we discussed, these are the number of infinite solutions. Like these are the some important example for the no solutions and unique solutions and many solutions. Yeah, here also the echelon form is the last row A minus 3, B minus 9. Based upon the conditions, we clearly understood it is no solutions whenever A is equal to 3 and B is not equal to 9. And again the unique solutions, here also A is not equal to 3 and B is equal for any values, and infinite number of solutions, A is equal to 3 and B is equal to 9. And similarly any equations are given, we need to identify under the non-homogeneous equations, the equations are like unique solutions and again the no solutions and also similarly infinite number of solutions. And this is also one different type of the example for to find the solutions completely. Here when we are going to observing in this problem, it is the equations are x plus y plus z is equal to 1, x plus 2y plus 4z is equal to lambda 8, and again x plus 4y plus 10z is equal to lambda square. With the help of the given equations, we need to assume in the augmented matrix and reduce the echelon form. Here they are asking to find out the system of completely, means we need to find the x comma y comma z, and again if and only if rank A is equal to rank AB is a condition. Here already existed in this problem rank A is equal to 2 and it is required, it is a consistent, automatically rank AB is also same by equating the last one lambda square minus 3 lambda plus 2 is equal to 0. Here by solving the lambda square minus 3 lambda plus 2 is equal to 0, we obtain lambda is equal to 1 comma 2, and with the help of this case 1 lambda is equal to 1. Here while we are going to replace in the matrix echelon form, here rank A is equal to rank AB is less than n, and again the system of equations having the infinite number of solutions. And similarly here after replacement of lambda is equal to 1, while we are going to replace in the given matrix, the equation is reduced to x plus y plus z is equal to 1, y plus 3z is equal to 0. By solving that, we obtain that x, y, z is a value. And similarly, the case 2 also, while we are going to replace the lambda is equal to, here also rank A is equal to rank AB is less than n is a condition. Here after replacement of lambda is equal to, the matrix is reduced like this. And here also we need to solve x plus y plus z is equal to 1. And again, x 0 into x plus 1 into y plus 3z is equal to, that is a 1. By solving here also, by taking that z is equal to 1 or k be any arbitrary constant, y also and x also in terms of k is the value. And similarly, any number of problems are given, we need to find the solutions with the help of the conditions under the non-homogeneous equations. When it is a unique solutions, when it is a infinite solutions, when it is a number of no solutions, and what is the conditions. And these are the some more example we need to practice. Yeah, further any doubts are there, please try to give the reply. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.